Leadership Fellow for Women Who Code Python track. Excited to see all of you here today. Thank you for joining our session today, 10 Tips to Code Like a Pythonista, with Poojita Garg. And please welcome our amazing speaker, Poojita, and I will read her speaker bio. So Poojita is a mastery in CS student at Georgia Tech with over 3 years of research experience in computer science. She has authored several research publications and has been granted a patent for one of her inventions. Her research focuses on enriching human-computer interaction by developing user-friendly mobile applications, employing Internet of Things, and applying machine learning. She is also a passionate advocate for women in technology and also serves track lead for New Code Mobile and Python Digital Tracks. When she is not a techie nerd, it's like nerd is like a good word, Poojita. So she's also learning a new language, playing notes on her guitar, or even dancing on some beat. So Poojita, thank you so much for being here today. I will now pass the session over to you.
Yeah, thank you so much, Eliza, for a wonderful introduction. Thank you, everyone, for attending my talk. And I'm really excited for the talk and hope you all are too. Okay, so without any further ado, let's begin. So today's talk is about 10 tips to code like a Pythonista. And yeah, let's dive right into it. So to start the talk, I would like to talk about our worlds, that is the coding world. So in our coding world, clarity of coding logic and readability is the priority, although it doesn't happen often. The more lines of code in a script, the harder it is to understand and to debug it. So we need to take more care of how we write the code and so that later we can maintain it easily. Now imagine yourself reading your coding project in 10 months. Your expression would be something like Monica has. So, unlike many programming languages, writing concise code can be easily done in Python. Here are some of the benefits of one-line coding. So what do I mean by one-line coding? So in Python, this is the word that's given when you write very less number of code, because there are lots of functions that help you, write your code concisely in Python. So we generally, in a layman terms, refer it as one-line coding in Python. So some of the benefits of such type of coding is that it is easier to read and it's easier to maintain and debug. Also, additionally, it reduces the local memory, complexity, and execution time. And also the confusion, especially when the script is co-developed with others. So this is a simple example of some part of the code that I wrote, which is about replacing some of the capital letters with the lowercase letters and replacing B with all the P's in a block of text. So the first part of the code that you see here is the normal code that you write with a lot of for loops written in this format, and with the other things like opening, closing of files written like this. But to avoid confusion here and to reduce the number of lines, I can easily convert this sort of code into the code that you see after the arrow. So it both will do the same function, but this is how concisely you can write. So that is always an option, to concisely write your code in Python. So this is just one example to give you an idea of how many number of lines you can really reduce. Okay, so I will not talk much about the theory and everything. We'll dive right into the code. So this is the Collab notebook. I'm going to switch back to the Collab notebook, and then we'll continue the rest of the talk in the Collab notebook. So coming to the Collab notebook, so I will be talking about 10 different functions or ways of coding in Python, which will really help you to increase your efficiency when you code your next Python project. So for all those who want to code along, you can use the link that I've provided. It's in the viewer mode. So what you need to do is you need to go to File, you copy this, save a copy in your drive, and then a copy will be saved in your drive. So I'm going to do that now. Awesome. So the copy of the original project is saved. Now you can actually edit this as you like. Okay. So before going to all those, amazing functions that we're going to discuss today, let's talk about Zen of Python. So a Pythoneer named Tim Peters once wrote 19 principles stating how one can write beautiful and clean code in Python. So it came to be known as the Zen of Python, and these basically are the guidelines to motivate the programmers to write, simple, readable, and clean code. So let's start that. Now you can view that 19 principles, the Zen of Python by Tim Peters, by running this statement that is import this, and then you'll get all those 19 principles. So there are a lot of principles, but some of the ones that are particularly important for us today are, simple is better than complex. That is the third one. Complex is better than complicated. That is the fourth one. And if the implementation is hard to explain, it's a bad idea. And if the implementation is easy to explain, it may be a good idea. So yeah, these were the ones I thought are particularly important for today's talk. Well, you can read all of those later, and you can see how and help you guide. This will help you definitely guide through when you're coding your projects. Another thing I want to discuss beforehand is the time it function. So if you remember when I was talking about the benefits of one-line coding, I did mention that when you code in less number of lines or you use some functions which are more optimal to use or efficient, they will help you reduce your memory, it will help you save the execution time. So this time it function helps you time your execution time, right? So it helps you give tell you what the execution time is required for your code. So there are multiple ways to use this timeit library. I have just used one of this method to let me see how much execution time is involved in my piece of code. So actually this is something different. This is now 20 by 20. So I've just wrote the simple code of populating a 2D matrix, a 20 by 20 matrix with all zeros, just to give you an example of the timeit library and function. So I've used this in this form that when you write a piece of code, you put it in a format of a string, and then you use this timeit function of the timeit library, and you have the argument as that string of which you want to find that execution time. And if you run this, you will get these time in seconds. So this is the number of seconds that is used to execute this piece of code. And when I changed, I used this one line coding mechanism of that same code doing the exact same function, I see that my execution time is considerably reduced. And this will be even more prominent when you'll have like a bigger sort of metrics, let's say 100 by 100 metrics, 1000 by 1000 metrics, and so on. So 20 by 20 was relatively a smaller number, but I wanted to show the difference. And this will be more prominent if you are dealing with lots and lots of data. Okay, so on this note, I hope now the benefits of online coding are very clear. Let's go on about some examples where and when you can use different functions, which Python really nicely provides us with. So the first thing in our toolkit would be just starting very basic printing patterns. So I hope when you all start learning Python, it's very common to start learning printing patterns, right? It's very amusing, it's very nice and very easy also. So usually when we start having hands-on with the for loops and everything, we try these sort of codes out. So this is a very simple code where I want to print this kind of a pattern with this emoji, using a cascading for loop for this, right? So, however, I can also do the same without a number of for loops. I can do the same and print the same pattern in one line coding using the join method. So it goes something like this. So you have the print function, you want a new line character. So this is a new line character. And with every new line, you're joining something. You're joining, and in the join function, you have what you want to print. This is a multiplication sign, or you can say this asterisk sign. Now, it is not just used for multiplication, but could also be used for a string. So if you want to print the multiple copies of the same string, you want to multiply that many times, you use this multiplication function. Um, in So that is like this string into I many times. It will print I many times for I in this range, which is range. A range is a function used for how many times you want to repeat something, how many times you want I to be in. That is 1 to n plus 1. So this will actually give you the same pattern. Oops, I think I should do this. Okay, so let me just quickly write the same line of code just to make it a little more interactive. And we'll print the inverted triangle pattern, which you just saw, for 10 lines with this basketball emoji. And I will use the same join function. So let me just start with print. I want a new line character. I will use the join method because I want to make my code very easy to read and also easy to write, save my coding time as well. I'm gonna copy this emoji here. I want to multiply it. I mean, how many times I want in a single line is n minus I, because I want an inverted triangle this time. So for I in range, and I want from 0 to n plus 1. Let me see. Okay, so we have this. This is the inverted triangle with the basketball emojis. Okay, so let's hop on to the next one. That's creating lists. So we all know how many times we use lists in our code, right? So lists is an important thing in writing code in Python. So there are multiple ways you can create a list. So there's this list function that directly helps you create the list by just using it. Also, there's another way that's called list comprehension, and that is very important. So sometimes we forget to use list comprehension and we are just bogged up with using different loops. And when we use different loops, our complexity of the code increases, right? So what we want to do is use list comprehensions, and it's just very easy to use once you know how to use it properly. So the list comprehension is a very easy way to make lists. So you will start with the square brackets, which are, which actually symbolizes list. So you see the ls is equals a square brackets, and then you want all the i's for I in range of 5. So it will print something like this, that the list one is 0, 1, 2, 3, 4. So all the range of 5, it will iterate all over it, and then we put them all together in a list. So it is very easy. Now, I also want to point one thing out here, that the examples that I'll be using today would be very simple and would be very easy to use, like just 5 characters. So really, it won't matter if you use like one line coding practice or you use any other function. But in a real world scenario, when you're coding for a big project, you would be needing a lot of these characters, a lot of data. You'll be working with lots of data. So the difference, what it makes to use one line coding versus not using that, will actually be very prominent. So yes, so this is just to demonstrate basic functions. Yes, so this is how I use list comprehension. Let's talk a little bit more about that. So list comprehension in Python is an easy and compact syntax for creating lists from a string or another list. So you can do lots and lots of things in the and easily create a list output. It is a very concise way to create the new list by performing an operation on each item in the existing list. So list comprehensions are considerably faster than processing a list using the for loop. Now, there's another very similar sort of thing called generator expressions. So generator expressions work exactly like list comprehensions, but without creating an actual list in the memory. So the numbers are created on the fly without storing them explicitly in a list. So when you really don't want the whole list in the memory, you just want to process each element, that's where you use generator expressions. So these are best if the list is intermediary. So let's talk where to use generator expressions and where to use list comprehensions briefly. First of all, the differences in the syntax. Generator expressions use these parentheses and list comprehensions use the square brackets. In terms of memory, a generator expression is lazy, so it follows a lazy approach of execution. It creates a single element based on request. So whenever you are doing any processing on single element of the list and you don't really care how many in total elements are there in the list, or you don't want the list as a whole at the same time, you use generator expressions. It will save you memory. And but there's another thing. Once a generator expression has been consumed, it can't be restarted or reused because it's not storing the complete thing altogether. So let's see some examples. This is a list comprehension, right? So I'm using square brackets. I am printing hello as many times as I in range 3. So 3 times I printed hello. Now, if I want to print a generator expression using the same code, then it will give me a generator object. So it is just giving me a pointer generator object. I might want to, convert it into a list to display it using the print function, or just to display it. So it is giving me a generator object at some memory, which is memory location. Now see, calculate the sum of squares of the first 20 numbers. Now, so when I want to calculate the sum of squares of the first 20 numbers, I not necessarily need the whole 20 numbers altogether. I can, have the square of one number, and then I have a location where I'm adding those, adding all of those numbers. So I really don't need to display the whole list, right? I don't need the whole list. I need a single element, then I will have that added to the other element. So I need one element at a time. So these both using the list comprehension, where I'm using this square brackets and having this in the parentheses, which means it is a generator expression, will yield me the same result. But I really do not need that much memory to store the whole list altogether. Just to give a highlight of how we tackle the real life problems, right? Like the big problems, other than just like having the sum of numbers or something. Just to give you a feel of that, I have this example which is nearly like a real world sort of example, where you work in a law enforcement department of US government of labor, and you are finding companies that pay below the minimum wage, so you can initiate a further investigation. So this is just a very fictional scenario. So here's your weapon. You use the Python's any function. So you are going to use another Python's function, which is any, which will give you the specific company which is paying any of its employee, like even if it's one of its employee, wage minimum lower than the minimum wage. Okay, so in this we will use the generator expression. So this is the companies, this is the data that we have. It's a fairly smaller data, just to make it easier. So this is the data that we have. It is a dictionary of dictionary. The whole dictionary this is the company, which is a cool company, cheap company, so-so company. And these are the employees that it has and the wages respectively, which are provided to those employees. The one-liner code for finding those illegal sort of companies which are paying their workers less than the minimum wage. So the code for that in one line would be something like this. So I want to find the companies. So I want to find X for X in companies. I want to find the companies. If so, this is the conditional statement. Only if I'm using the any function, that means it will yield even if a single worker is paid less than the minimum wage, it will give me an answer. So I'm using this any function, and inside this any function, I'm using a generator expression because I don't want the complete thing. I want a single element. So I want to process the single element at a time. So this y is the company's values. So companies of X, so it will iterate over each item of the bigger dictionary, and then it will go to its values, which is another dictionary, and then it will check all these values. Okay, so if y is less than 9, for which 9 is your state's minimum wage, let's suppose that. So this will yield me all those y's which are less than 9, and then give me the companies for it in form of list. So if I print this, I find that the cheap company and the so-so company were illegal, in fact. So this is just to give you an example of like a fairly complex sort of situation than what we are doing earlier. Okay. Okay, so another important concept that I feel is slicing. Now, it is also sometimes a little confusing, especially if you are a beginner in Python coding, but slicing is also very important. So to understand it very nicely, I have given some introduction of slicing. Its syntax follows something like this, which is X is some iterable, can be string, can be list, something like that. Then inside the square brackets, you have these three parameters, which is start, colon, stop, colon, step. So you start with the starting index. So here you provide indexes, indices. You start with some index, you stop. So the start is always included and the stop is always excluded. Step is a optional parameter in which you want to like give, if you want like something like only on odd positions, uh, print something which is only on odd positions or only on even positions or some other step, maybe, then you use the step parameter. If it's not mentioned, then it will follow the default step, which is 1, which is every other element. Okay, so we will take some examples for slicing. Now let's say that I have an iterable which is a string which says eat more fruits. So yeah, it's really important to eat more fruits. So I have this s which is eat more fruits, which is a string, and then now I am slicing it. So I want to print something which is s, which is a string, a variable containing a string, and then I have nothing, and then I have a colon, and then I have 5. So if any of these parameters, start or stop, is not mentioned explicitly, the default is that it will start from the beginning and it will end at the very last element of your iterable. So now here I have given it a stop, but I have not explicitly given a start, so it will start from the very first item. If I print this, let's see, it's giving us eat m, which is have exactly the 5 steps, and the step is not given, so it is every other element, so it is giving us this thing eat m. Now here the blank space in between is also considered as one element. Okay, let's take a few more examples. Now here I have given it as it is going to start at the index 3, but it's going to stop at index 0. So I think that is an issue. And since I cannot see the chat, but you must have predicted, like I cannot start with the index that is greater and stop an index which is lower than the starting index. So that doesn't make sense. Even when my default step is +1, right? So this doesn't make sense. So it did not give any result. Now let's take some other example, which is I'm starting at 4, I'm going up till 8 index and with a step count of 2. So you can, check with our string, but this is the result that it yielded. Now let's talk about this one where my step is -1. So it is perfectly fine if you provide explicitly that your step is going to be -1. That means it will start from the last position and it will go up till the initial position with a step count of -1. So it will yield something, a reverse of the iterable that you have provided it. It's very similar to the second example that we did. Here, I'm starting with a bigger index, going up till a lower one, but I've provided a step count of -1, which makes it perfectly normal to execute, and this is what it yields me. Okay, so let's hop on to the next function since we don't have that much time. Sorry that I'm being a little fast in pace. But yeah, you have the collab notebook with you, so you can read it through. So I've also added these sort of introductions to each function for easy readability. Okay, so zip function to format databases. So this is another function in which, sometimes you want to change different like tuples. These are sort of called tuples, right? Like 1 4 2 5 3 6. So I want to zip them together, right, in different items or different elements of the list. So I use this zip function. Let's see how the zip function like is executed. So I have different iterables. I have two iterables here, and if I wanna I mean if I wanna club like element at each position of both of these iterables together, like 1 to 4, 2 to 5, 3 to 6, and I want to zip them together like this, I will use the zip function. Again, let's see some example about it. Now you imagine you are in IT branch of a controlling department of your company. Again, a fictional scenario. You maintain the database of all employees with column names, name, salary, and job. However, your data is out of shape. It's collection of rows in which something like this, right? And you want to associate your column names to each data entry to bring it in a readable form. So you want something like this, like name is Bob, salary is something like this, job is mid-level manager, and something like that. So how do you achieve this? So basically you have two iterables, which is one is the column names, and one of the iterable is the data that you actually want to associate with each column name. Now you can use the zip function like this. So you're using again a list comprehension. That's what I told you, that list comprehensions are going to be used like so many times. The list comprehension, and then you're actually making a dictionary out of the zipped, after using the zip function. Using the zip function, you have column names and rows, you're zipping them together for each row of DB rows. If I run this, I will have a dictionary, a list of different dictionaries. So I have different dictionaries. Like I have this first dictionary, I have the second dictionary with item and its value, key and its value, and then I have the list of all those dictionaries. And you can, have it however you want. Okay, so yeah. So before going further, I just want to ask Elisa if there are any questions in the chat. Up till now, I know it's a lot of content to consume in very short a period of time, but I hope you're having fun up till now, and you're gonna have even more fun after this. I mean, not the functions that I'm going to introduce right now are going to be awesome. Like these are also really important. So are there any questions?
Are there times when more lines of code in the program is like better for readability, I guess, for you or the next person reviewing it? And how do you find that like balance in between, like conciseness and readability?
Yes, I mean, surely, if you have like everything, sometimes it definitely needs to have balance, because if you write everything in one line, and if you are not that experienced in coding in that specific language, you will be like, oh, where this function came from, what is happening in the same one big line, right? So I feel there needs to be like with each level of coding that you go on to be like, if you're starting from beginner, intermediate, and more advanced, you need to know what your audience is. Like if you are, let's say you are you are a core developer you're in a very big company, and the core developers which are there with you, the fellow developers, are also advanced level coders. I mean, at that time, I think I mean, it's easier, right? Like if you're advanced coder and the other person reviewing your code is also an advanced coder, they're fine to review it. Like they know exactly how these functions are used. But if your audience is like, if it needs to be, if let's say it's your assignment for your university project and it's the professor who needs to review it or a TA needs to review it, you don't know exactly what their expertise level is, or exactly you need to be very very elaborate in your assignment, like this is why you did this is the next step that you performed in your code and everything. So there I feel the other practices of documentation, the other practices of documenting your code are necessary, like adding comments, having good indentations and everything, having a very nice clean code. Like there are obviously different other necessary documentation stuff that you need to do. But here it's more like these 10 tips are more necessary when efficiency of the code is what matters the most for you. If solving the problem matters most for you, if you want to just have, if you want to solve something like maybe in hackathons, right? If you want to solve those codes like very fast, as fast as you can, you want to use less memory, you want to be very fast in your coding, I mean, that's where these will be handy the most. But yes, there needs to be a balance, and we should always maintain that balance and know your audience as well. Okay, so if there are no other questions, then I can go ahead. Okay, so the next one is the Lambda or anonymous functions. So these are also really important to know and to use. A Lambda function is a small anonymous function. So you know how functions are coded in Python, where you define them and then you actually use them, right? So a Lambda function can take any number of arguments but have only one expression. So something like this, Lambda, that is the keyword. Then you write the arguments, and then you have a colon, and then you write the expression which you want to execute. The expression is executed and the result is returned. Caveat is that you can have as many number of arguments as you like, but you can only have one expression. So only one thing that can be returned. Example, this is a very small example. You are just adding 10 to a number, just adding a plus 10, just returning that. You defined a function, so def function, you defined this function which had a as argument. You are returning a plus 10, and you're calling that function in the print itself, and a is 5, and then it will return 50. Voila. How to use Lambda function for such an easy function, right? And this, I really did not need to define the whole function, because that's not necessary. So for such cases, you just use Lambda keyword. So in the same line, you use Lambda keyword, you provide your argument, let's say, and then whatever processing you want to do on that argument, and the result you want to return, that is a plus 10. You will use this x, which will act as a variable that is sort of pointing to your Lambda function, right? So you will use this x equals something. Then you are going to use the same syntax which you use for functions, that is x, and then these parentheses, and then you given the argument that you want to use, right? That's 5. So this will again yield the same result. For practice, you can use like summarize argument a, b, and c, and then return the result. So I did, and this has more than one argument, but I want to summarize those, so I can only use one expression, which is a plus b plus c. That's my expression. A, b, and c are my arguments. So lambda a comma b comma c equal colon a plus b plus c. So there I provided 3 arguments, 3 parameters to these arguments, and this gave me 18 as my result. Now let's go on to map functions. Map function returns a map object, which is an iterator of the result after applying the given function to each element of a given iterator. So you provide 2 things in the map function. You provide the function that you need to perform on each element of the iterable, and now you also give it the iterable. Let's see how it is done. Now here I made this function, addition function, which is adding the number to itself, n plus n. And then I have this numbers list, 1, 2, 3, 4. And now I use map function because I want the double of each element. I want a list which has a double of the each element. So this is how I'm using the map function, where I use the addition, which I defined earlier, the function, and this is the iterable numbers, and I'm printing it form of a list. So I have this 2, 4, 6, and 8 as form of list, and which is double the numbers list, basically, you can say. Now, in this case also, while using map function or any other function, you can use inline lambda also. So this is sort of inline lambda. In some other piece of code, you do not explicitly need to define what that lambda function is. So you're just using it in form of inline method. You have this again, the same iterable. You want to do the same thing, double all in numbers using map and lambda. Instead of defining explicitly your function, whatever processing function you are using, if it is simple enough to be used by like lambda as a lambda function, you should use that. Use lambda x plus x, that is what you want to return, and you want to do that on the iterable numbers. You just have map, so it gives you the same result. Once you start using these sort of functions, right, like lambda functions, list comprehensions, generator expressions, you will get a hang of it, and then these will be the things that will help you like ease out your coding process. Like you really don't need to create the whole, not create, like define your whole function at some other place and then do that. I mean, it's very easy for such type of expressions that you just use the lambda function. Okay. Going forward to filter functions. This is another function I found interesting, which is the filter method that filters the given sequence with the help of a function, that tests each element in the sequence. This is also something which we usually use if you want to filter a list out or an iterable out on some basis. Then we use some function, we need some function and then an iterable, and it goes through all of its elements. So usually if you don't use this function, right, you are going to do it using some loops. You're going to use a loop, let's say for loop. You're going to check each element in the for loop, and then you want to have the whole function. It will be all like a lot of lines of code, a lot of things that you want to do. So this will just save you that bunch of time. Okay, so the syntax is pretty simple, is very similar to the map function, which is use the filter keyword, have the function in that, and have the iterable in it. It will return you an iterator again that is already filters. Easy. So in the filter function, I will not explain the code now. So it will use both of these things that I told you, like using the syntax. Then you can similarly use the lambda function as inline function for the filter function and use the iterable, and this will also yield you the same result. Another function is the reduce function, and it is part of the functools library. Again, the syntax is like this, in which you can also, reduce function is used when you apply a function to two arguments cumulatively to the items of iterable from left to right, so as to reduce the iterable to a single value. So if you want to just condense it to a single value, maybe do multiplication of elements or something like that. Again, you can here use lambda function as its inline function. The last one is the accumulate function, which makes an iterator that returns accumulated sum or accumulated results of any other binary function, which is mentioned in its function parameter. So using the syntax which is mentioned, you can condense those elements, perform that function that is given, and there also you will have the the answer to it. There's also the reduce and accumulate function works very like similarly, but there are some difference. Like reduce function will return only an accumulated value, whereas accumulate function will return the running accumulated value, like a cumulative sort of sum, like sum or whatever function that you want to do, but it will give you accumulated values. So yes, these were the 10 different functions that seemed to be really exciting for me, and I also started using them in my own coding practice. And I hope you enjoyed this talk.
I'm really looking forward future talk sessions from you on this subject. I feel like everyone's really learned a lot from you in this session, and it was amazing, like this talk. Thank everyone so much for being a spectacular audience, joining this session.